Section 6.3, Symbolic Replacement. Symbolic replacement simply means replacing symbols with numbers. This is also called substitution. Example, simplify y plus 4 when y is equal to 7. What we're going to do is we're going to replace the symbol y with the value 7. 7 plus 4, and then simplify. 7 plus 4 is equal to 11. Example, simplify x minus negative 3 when x equals 5. Don't be confused by all the extra symbols. We are replacing the symbol x with the value 5. And then we simplify. 5 minus negative 3 is the same as 5 plus 3, which is 8. Example, simplify a squared when a equals negative 6. It's very important here that you recognize that the a is being multiplied by itself, and the a is the entire number negative 6. So we need to use parentheses around this to indicate it. Negative 6 squared in this form is equal to 36. Notice what happens if we were to try to write this without the parentheses. Remember that the exponent applies to the object immediately to the left, and so this would have ended up being negative 36 and would have been wrong. Example, simplify negative n squared plus 4n when n is equal to negative 3. Even though we see the number n showing up in multiple places, in any particular problem, it takes the same value. Negative n squared plus 4n is equal to negative 3 squared plus 4 times negative 3. And now we simplify this according to order of operations. The exponent here turns this into a negative 9 plus negative 12. And negative 9 plus negative 12 is going to be negative 21. Section 6.4, word-for-word translation. An important skill is to be able to translate mathematical symbols into English and English into mathematical symbols. Translating from math into English is a matter of reading the symbols out loud. Example, translate 3 plus 4 equals 7 into English. Since I've read the problem out loud, I already know what the answer is. 3 plus 4 equals 7. As long as you're able to read the symbols out loud, you should be able to translate from math into English. There's an important distinction between a negative sign and a minus sign, and that can only be understood from the context. Example, translate this into English. Right here, this is a negative 8, that's a minus sign, and that's a negative 3. Negative 8 minus negative 3. Subtraction will always be an operation on two numbers, but the negative sign will only operate on one. In the example above, we have our two negative signs, negative 8 and negative 3. Those two signs are only operating on the number to the right. The negative applied to the 8, negative applied to the 3. The subtraction symbol in between them is operating on two numbers. It's creating a relationship between the number, negative 8, and negative 3. Sometimes translating from English to math is a matter of matching words and symbols. For example, translate 5 times negative 2 into symbols. If you just read it going across, 5 times negative 2, you get it correctly. However, it's not always this simple. There are situations in which the translation requires symbols to be rearranged. Example, translate the sum of 2 and 3 into symbols. If you already know what the words mean, you will recognize this as 2 plus 3. But if you look at the words, the order of the words is different. The 2 is here, the 3 is here, and the sum shows up in between them. Now some students may think that the word and is the thing that's telling you to add, but that's incorrect, because we could say the product of 2 and 3 and get a different result. So the answer here is 2 plus 3, but it's not a literal word-for-word translation.